Okay, so let's get this presentation started. Hello, my name is Marcin Wielgus.
And I'm Maciej Pytel.
And today we will talk a little bit about autoscaling. And actually we have one additional person who will help us on this talk, at least at the very beginning. And I guess this guy doesn't need an introduction here. Everyone knows Bruce Lee. So he once said a very nice sentence. A wise man can learn more from a foolish question than a fool can learn from a wise answer. You are on KubeCon, and more importantly, you are on our talk, so you must be wise. So we will start with a couple of questions. And there are various questions that people ask in their life. Some of them are trivial, like what should we eat for lunch? Some of them are turning your life upside down, like will you marry me? And obviously, there are a couple of foolish questions. But today, we will focus on a question that is slightly different. Mainly, how much resources do you need in your cluster? If you ask this question to application developers, you will get various answers, ranging from, I don't know, or it has not been yet decided, to a semi-random number, like let's say 42 CPUs, which is probably much more than the application really needs. Sometimes, if you are lucky, the developers actually did some tests at some version of the application based on some rough impression of what the application usage may be. If you are lucky, these estimates may be quite accurate. However, more often than not, these estimates are lacking one most important factor: the change. In the modern software engineering world, the version changes all the time. Continuous delivery pipeline pushes in new versions over and over. The new version might be either faster than the previous one, or there might be some performance regression which may not necessarily be caught by the tests. The traffic may change. Some real-world events may cause a sudden inflow of requests. Newly launched feature may make your application much more popular, or miscommunication between development teams may result in the inappropriate API usage, and so on and so on. And these changes may cause you a lot of problems. Your application might crash or become unresponsive and drop shame, grief, and a serious embarrassment on you. Not to mention financial implications for your company and your future personal career. You might have a superhero on your team, someone with special powers, like full root access or unlimited budget on your cloud provider. A friendly DevOps Spider-Man from the neighborhood who will fix your resources and load problems. He may save you once or twice. But superheroes may get tired of saving your butt over and over. Also, they want to have a good night's sleep, personal life, evenings and weekends off duty, vacations, sick leave. And you should not strongly depend on them. So, you need a robot that will take care of your cluster and your application day and night, without getting tired and with no personal life. A robot called autoscaling. The mission of this robot will be to automatically adjust resources to match the current needs. But what does it actually mean? The first goal of autoscaling is to save you from this: crashing application outages, unhandled requests caused by increased load or performance impacting changes. The second goal of autoscaling is to save you money. Based on the first goal alone, you could just provide an insane amount of resources, pods and stuff and call it a day. But obviously, you don't want to pay an insane amount of money. You probably want to pay just what is pay for what is really needed. So the ultimate goal of autoscaling is to automatically keep the right balance between what you pay and how much spare capacity or resources you have in your cluster. So let's focus on this problem. How to maintain the decent load in your application. You can think about pods and application as pipes. There is some water, traffic, coming in through the pipe. You don't want the pipe to explode due to high pressure or be underutilized because it would mean a waste investment. And as you can see here, there are meters with some gauge attached to the pipes. There are some values on these meters that are indicating that the load starts to be unsafe to the pod. For example, when it is using more CPU or memory than it has initially requested. If the loads go above the safe threshold, it might be beneficial to start a new pod. Luckily, starting a new pod is much easier than laying new pipes. Thanks to deployments or stateful sets, getting yet another pod is more similar to cutting a cookie than laying a new pipe. Let's take a look at some more concrete example. Let's imagine that the gauge shows the ratio between how much resources a pod really uses and the pod has initially requested. On this example, we have 4 pods. They are burning hot. They are almost out of their capacity. Should there be any traffic increase, there might be not enough computing power to handle it. However, if we add a pod to and the same traffic is spread across 5 pods, then the average per pod load will obviously decrease, leaving more space for the spikes in the future. If the situation is slightly different and the pod load is, let's say, below 50%, meaning that more than half of the resources are wasted, then it might be actually beneficial to remove 1 or 2 of the pods, and then the remaining pod will be handling slightly more traffic and the requested capacity will be better utilized. In general, we want to specify a target, not too big, but not too small. Something that we would be happy with. Then the Autoscaler will try to add and remove replicas to move the load more towards this target value. And this is what horizontal pod Autoscaler in Kubernetes does. Horizontal pod Autoscaler is built into the core of Kubernetes from quite a long time. It adjusts the number of replicas to maintain the target load. But what is the load exactly? For a long time, horizontal pod Autoscaler understood the load as the ratio between the actual CPU usage and the requested capacity, because actually the underlying monitoring infrastructure allowed only this. There was a hipster, which is now replaced by metric server, that scraped basic metrics like CPU and memory usage for all containers running inside of the Kubernetes cluster. And we created a simple controller that talked to this hipster/metric server thing that obtained the utilization, and based on this utilization, it scaled the deployments or something else up and down. Okay, so we have the CPU-based scaling. However, CPU utilization is not the only way to express the load. For some people, the best metric expressing the load would be request per second. For others, something like queue size if they are running, let's say, batch processing workloads. For others who would like to have something more SLO focused, the good metrics would be the latency. And for that reason, some time ago we introduced custom metrics to horizontal pod Autoscaler. With custom metrics, users are allowed to point horizontal pod Autoscaler to some metrics stored in their monitoring solution and scale based on it. On Google Kubernetes engine, the metrics are maybe stored in Stackdriver. On some other cloud provider or on-prem, it might be Prometheus or something completely different. The pods or some other entity pushes the metrics to the monitoring solution, and then horizontal pod Autoscaler controller gets these metrics for a dedicated adapter, and based on the actual metric value, it adjusts the number of pods. Okay, how to use it? As I said, horizontal pod Autoscaler is controlled by an API object. So to configure it, you need to create an object, point it to the appropriate deployment, replica set or something else. You need to come up with the right metrics type for your scaling. So, for example, a CPU load or something more custom. You need to express the target load. For CPU utilization, a good value would be something between 70 and 80%. You probably shouldn't go much higher, because then you will not have much space for spikes, and any scale-ups in the future may be slowed down. For the CPU load, you may use kubectl autoscale command, and it will create the HPA object for you. For custom metrics, you need to play with YAML a bit. When to use it? Horizontal pod autoscaler is the best for stateless serving workloads. Something like Nginx, front-end server, or a lightweight microservice. Something that starts reasonably fast and can be removed and added at will. You need also the right metrics to drive the scaling. The metrics should be of a gauge type. So stuff like counters that go always up are not really okay. HPA is not the best suited for stuff that is stateful, although with the appropriate care, it is possible to scale stateful sets with it. I showed you one way of dealing with the load. Let's take a look at the other one. Those of you who have kids are probably aware of this problem. You are in the constant process of buying new clothes, new shoes, new trousers, new jackets, and so on. For some reasons, this clothes doesn't have a knob that would allow you to adjust the size as the kids grow. And if you don't act proactively, one day, at the worst possible moment, the kid will say, "Daddy, I don't wear this, it's too tight," and start crying if you try to put it on for the very last time. And actually, having small shoes, for small shoes, by no means can be a substitute for the pair in the right size. Grown-ups are not much easier. We lose, and what is unfortunately more common, we gain weights, making the previously bought clothes obsolete. And in Kubernetes, we have similar situations. Applications grow, the containers are too big or too small, some workloads don't scale well horizontally. And for these workloads, we have vertical pod autoscaler. It adjusts container sizes based on the real-world usage. Let's take a look at this case. We have a pod that is constantly using 95% of its resources. It's not the safe situation. If any traffic spike comes, there will be no space to handle it, or the container may even crash. In this case, the pod size should be increased. If it's increased and, for example, the traffic stays in the same place, then it stays at the 70% load. So there is a space for the spikes, so it's much safer situation. Vertical pod autoscaler is simple. There is a recommender that provides pod size recommendation. There is an updater that checks whether the pods are under the pods under VPA have good resources request, and if some of the pods don't have good resources, updater is responsible for restarting them. And once the pods are restarted, they are assigned the right request by admission plugins. And vertical pod autoscaler can work in three modes. The one is to assign recommendations at the very beginning. The one is like a full trust mode in which you give full control over your deployment to the vertical pod autoscaler. Or if you don't want to trust vertical pod autoscaler, it can work in a dry run mode in which it provides you only with the recommendation that you can apply or not apply on your own. How to use it? Vertical pod autoscaler, similarly to horizontal pod autoscaler, is controlled by an API server object. But in this case, we are not built into the default API. It's a custom resource definition. And if you are creating a VPA object, you need to select, obviously, a set of pods you want to scale. Using a label selector, you need to decide which mode, so either anytime full auto or dry run mode. You need also to specify boundaries in which VPA should work, like minimum and maximum size of the container, and so on and so on. When to use it? As I said, VPA is suitable in cases where horizontal pod autoscaler is not an option. So, in cases when you need to have a fixed amount of pods, or you change the number of pods rarely. For example, to make sure that your stateful set always has enough memory. VPA is recommended only mode is used to investigate the right amount of resources that can be applied later in time. Okay, so as I said, vertical pod autoscaler is not a part of core Kubernetes. However, it is developed in Kubernetes repository, and if you want to learn more about it, it's here. So in Kubernetes/autoscaler repo on GitHub. Okay, so everyone likes spices, good spices. However, some really good spices don't always go well together. Can you mix horizontal pod autoscaler and vertical pod autoscaler at the same time? Well, not really, not yet, and not always. Please notice that horizontal and vertical pod autoscaler are trying to solve the exact same problem. They keep the right balance between what the pod consumes and what the pod requests. So if you run HPA and VPA for managing CPU-related stuff, you may end up with too big scale-up or too big scale-downs. Combining custom metric-based HPA and VPA is a bit safer. However, some extra care and consideration needs to be applied. Hopefully, we'll have a better story about this in the future.
Okay, so imagine you have your perfectly configured pod autoscaling already, and there is a big traffic spike in your cluster, and HPA reacts to it by maybe adding some more replicas of your application, or maybe VPA makes your existing replicas larger. The problem is all that effort is basically wasted if you don't have space in your cluster to run those new pods. I mean, I guess you can have monitoring and just add more VMs, but that requires some manual intervention and it's probably not very fast. Or you could approach this problem differently, over-provision and just always have enough capacity in your cluster to handle any possible spike. In that case, the problem is you're basically, most of your resources are going to be idle most of the time, so you're not very cost efficient. And modern cloud providers have a lot of capacity available on demand whenever you need it. So it would be pretty cool to be able to just use that and buy as much VMs as you need when you need them, and just stop using them when you no longer need them to save money. And that's exactly what node autoscaling does. So let's see how that works. Basically, what we're trying to do is to make sure we always have the right number of nodes in our cluster. And to talk about node autoscaling, we have to start with scheduling. Since this is the intro talk, I'll just sort of do a very high-level basic overview. So basically, Kubernetes Scheduler is the component that puts pods on the nodes. And each pod has a size. It's basically how much resources it requests. So maybe a small pod can only request a fraction of a single CPU core. And maybe a very large pod can request multiple, I don't know, 20, 30, 50 CPUs. And the same goes for memory, GPUs, and other resources. And the scheduler will only put a pod on a node which actually have enough free resources for the pod to run. So let's consider a simple example. We have 4 nodes, and each of them is already running a pod. And we have a new green pod, which has just been created. And I mean, just visually, we can see it will not fit with those large pods. So what the scheduler would do is it would just put it on the single node that actually has enough space for this pod to run. Now imagine the same scenario, but slightly changed. Our yellow pod is now also very big, and there is just not a single node with enough capacity to run our new pod. What will happen is basically scheduler refuses to schedule this pod. It will not start running. It will be pending forever. So what we would like our node autoscaler to do in this case is just add a new node so there is enough capacity to run all our workloads. Different scenario would be this. We already have 5 nodes, and each of them runs some pods. But some of them actually only run very small pods and have actually quite a lot of spare capacity. So what we could do is, if we move the green pod to the yellow pod, we wouldn't actually need this extra, the last node. We can run the same set of workloads the same way, except using less resources. So we're saving money here. And that's basically what our node autoscaler called cluster autoscaler does. It observes the pods in the cluster, and if it sees any pods that are pending, any pods that cannot be scheduled, it will add more nodes so those pods can be scheduled. And it also monitors all the existing nodes, and if it finds a node that is not very highly utilized and can be removed without disturbing any pods permanently, it will remove this node. And that's sort of a very high-level overview of how cluster autoscaler works. And the important difference between cluster autoscaler and pod autoscaler is pod autoscalers is what they look at. So HPA and VPA look at actual usage metrics. So basically how much your CPU actually uses and how that relates to what you would like it to use. Cluster autoscaler, on the other hand, only cares about the stuff that Kubernetes Scheduler cares about. It won't help you if you're actually, like, your pod requests way less resources than it needs to, and it just crashes because your node doesn't have enough resources. All it does is it makes sure that every pod can be scheduled, and that includes both resource requests and more advanced Kubernetes scheduling mechanisms. So for the best effect, it's good to use both pod autoscaling and cluster autoscaling. They are designed to complement each other. Okay, so how to use cluster autoscaler? Well, I mean, contrary to pod autoscalers, it lives in between Kubernetes cluster and the cloud provider. So basically, every cloud needs a specific integration with cluster autoscaler. And currently supported clouds are Google Cloud Platform, AWS, Azure, and recently added Alibaba Cloud. And unfortunately, the configuration is slightly different on each of those platforms. On GK, it's just as simple as running a single command. In other clouds, I believe you need to run your own cluster autoscaler deployment. And all the details are documented in our repo. So that's the best place to start if you want to run it. Okay, so now that we know how to run cluster autoscaler, the question is when to run it. And we like to think that the answer is basically almost always. Of course, you cannot run it if you're running on the cloud provider that is not yet supported. And maybe if you use some very, basically complex custom scheduling or something like that, it may be tricky. But otherwise, there is really no reason not to. And that's about it for node autoscaling. I'd like to proceed to the sort of status report part of our talk. Basically, where are we with all of those components? So cluster autoscaler is generally available and have been in GA for about a year now. So it's a pretty mature and stable product. HPA based on CPU utilization has been in GA for even longer. And HPA with custom metrics is currently in beta. Finally, VPA is in alpha, but we're about to graduate it to beta. So it should be in beta really soon. And what's the progress, or what are we working on right now in improving those features? Well, there have been actually quite a bit of effort recently on HPA. We've improved the algorithm a lot. I don't know if you used it previously, but it used sort of a blackout window where it would not scale shortly after a scale up or scale down, so the metrics can stabilize. So the new algorithm can actually handle it without this blackout, so it should react faster, and also the scale down should be more stable and safer. And we're also planning to add an API to give you more control over basically scaling speed and scaling parameters. Finally, there were in, I believe, Kubernetes 1.12 some changes to the HPA API that allows you more control over exactly which metric is used for autoscaling. On the VPA front, we received a lot of feedback from our alpha users. So if any of you use it in alpha, thank you. And we've basically managed to fix a lot of bugs and improve the stability. So we believe we're ready, or almost ready for beta. Finally, on the cluster autoscaler, we're mostly just maintaining it. We have done a lot of work to improve the performance recently. So we hope you'll be able to use it on larger clusters than before. And also there is an ongoing effort to integrate Cluster Autoscaler with Cluster API, which is a separate Kubernetes project. It's basically an abstraction layer on top of cloud provider. And we hope that once we integrate it with Cluster Autoscaler, you will be able to use it on more clouds without having to explicitly implement support in Cluster Autoscaler for each of them. So we hope it will get much more portable. What else are we doing in our SIG? Well, there are a few sort of system internal components. There are internal autoscalers used by things like metric server or hipster. We're mostly just maintaining those, and ideally we would like to replace them with HPA and VPA, but it may take a while. So if you want to just use autoscaling features, ask us about anything, contribute something to the autoscaling space in Kubernetes, we have a SIG meeting each Monday at 4 p.m. Central European time. That's the Zoom link. And we also have a channel on the Kubernetes Slack. And a lot of our most active contributors are quite active on this channel. So that's also quite a good place to ask us any questions or discuss any features you would like. Finally, most of our stuff lives in this repository. So that's a good place to look at the code or open any issues or just read documentation. The only exception is HPA, which actually lives in the main Kubernetes repo. And the very last thing I want to mention is other autoscaling talks on this KubeCon. So tomorrow at 11:30, me and Marcin will do a SIG Autoscaling deep dive, where we'll talk more about VPA and Cluster Autoscaler, sort of in more detail, talk about more advanced use cases and how it works internally. And our friend Alexandra will have a talk tomorrow at 3:05, discussing how to get Cluster Autoscaler to work on other clouds that are not yet supported, and basically what's involved with this. And that's it from us. Thank you very much. If you have any questions.
When using Cluster Autoscaler, we need to set utilization, such as 50% to scale down. A utilization value.
So you don't specify utilization directly, so it's not like
yes.
Specify target. Currently, there is a threshold when Cluster Autoscaler starts considering nodes as unneeded. For example, a node that has requests that the pods requested in 70% is quite useful node and should not be scaled.
Yes, but only one utilization value is not enough because maybe I have a multi autoscaling group. Different autoscaling group is for different use case. One is for big data job, one is for online workloads. But maybe they have different utilization value. But currently we can only set one, and one is for CPU, GPU, memory, and all the metrics. I think maybe we should have different utilization value and for different autoscaling group.
Yeah, that's a really cool idea. We would gladly accept a contribution from you. So if you feel that's needed, please send code. We may do it by ourselves. However, it may take a while. Anyway, most of all the Cluster Autoscaler code is in public. So if you think that something extra is needed, or there is a use case that we didn't thought about, please come to our meeting or send us PR or file an issue, and we'll gladly accept any contribution in that area.
Is there a plan to like support Prometheus custom metrics natively? Or I mean, right now you would need the adapter, right, to use it.
You need adapter because we want to be as generic as possible. Okay. So we have a separate API to get metrics that is independent of any monitoring solution that is on the market. So we don't want to bless any monitoring solution, for example, make Prometheus the only natively supported solution. So all metrics solutions are kind of considered equal, and all of them probably will require some kind of adapter, which is relatively lightweight. So it shouldn't be like a great problem unless you see a problem in it, and gladly hear your feedback on it.
Okay, no, I just thought maybe it's easier to support it. You can just say get metrics from Prometheus. And
yes, but there are other monitoring solutions on the market. So if we bless Prometheus, then I don't know, guys from Datadog would also like to have the same level of support, and obviously our company will ask us to do the same for Stackdriver, and we will be eventually supporting the whole range of monitoring solution in the core of Kubernetes, which we don't want to. Please remember that HPA sits in the main controller manager. So plugging there any libraries that are specific to a particular monitoring solution may not be well received.
Okay. Thank you.
I would also add to that the different monitoring systems have very different way of specifying time series in their database. So it's actually difficult to have an API that works for everything, and it's not very general.
We may have some situation that we know that in the future we have some activity, and we know like maybe tomorrow at 10 we have some request spike. So if I at current time enabled Autoscaler and we haven't so many requests, and it will scale down my resource. So how can I prevent this? Maybe well, I need to prepare for tomorrow that there will be a spike. The spike will be very high, and the Autoscaler will not scale my resource immediately.
Yes. So answering your question, you need to do it at this moment by yourself. So either you scale up your autoscaling groups, whatever node group equivalent you use on your cloud, or you can mark your nodes as unremovable, and then Cluster Autoscaler will not touch them. We don't yet have any integration of any of autoscalers with calendar. So you cannot say that, I don't know, at 1 p.m. on Friday, I need more capacity. Yep. Right now, it's not supported. We hear this request from the users from time to time. So maybe in the future, there will be. At this moment, we try to focus on some more basic building blocks. But definitely, it's a valid use case. And unfortunately, at this moment, you need to solve it a little bit on your own.
Thanks.
Any more questions?
Hey, welcome to Shanghai. And this is from HP. And my team is running the Kubernetes on top of AWS. It's EKS. Okay, and EKS use the cloud formatting to manage the nodes and scale out, scale in such kind of things. So my question is, if we use this cluster autoscaler, so is there any specific value we can be added on top of the EKS environment?
So unfortunately, we work for Google, so we cannot advise you on the use of EKS or whatever.
Okay.
However, there are some people there who support the support of EKS and other cloud providers. Please file an issue, and they will be the best person to answer your cloud provider specific question. Sorry, we basically don't use it.
Okay, that's fine.
Okay, I guess that will be it. If you have any more questions, you can catch us in the lobby. And thank you for joining us today, and hopefully we'll see you tomorrow on our deep dive.
Thank you.